Welcome to the lesson on graphing polar equations. Our first equation that we want to graph is r equals 2 cosine 3 theta. In order to graph a polar equation, we need to change the mode of our calculator to polar form. So the first thing you need to do is to type mode, which is just to the right of the second key. Once you press the mode button, you're going to scroll down and over. We're going to scroll down to this row that says function, parametric, and polar. So we're going to scroll down to that row, and then we're going to scroll to the right to highlight polar. Once you have put your cursor on the word polar, to choose it, you're going to press enter. Now we're going to quit this screen to come out of it. So press second and then the mode button again. That'll quit that screen, and we're ready to go to the y equals, or to graph. So all the graphing buttons are on the top row, so we're going to press y equals. Once we press y equals, even though it says y equals, notice that what comes up is r equals, because that's polar form. The calculator automatically changes from y to r, and it also automatically changes from x to theta. So we want to type in 2 cosine 3 theta. So we're going to type in 2 and then cosine, and now we're going to type in the 3. Notice after the cosine it opens a parentheses, which we want it to be there, and then the x button will now be, when we press it, a theta button, because we are in polar form. We do want to close our parentheses. Alright, so we want to go to zoom standard. So we're just checking out the graphing button in case you've graphed something prior to this. We want to make sure that our graph looks the same. So let's go to zoom, and then we're going to go down to zoom standard, which is number 6. To do that, you can either scroll down to number 6 and press enter, or you can simply press the number 6. So I'm going to scroll down and press enter, and here is my graph. It's kind of teeny tiny in my opinion. So what I want to do is I want to make it bigger. So one way to make it bigger is actually to go to zoom box, and zoom box is basically lets me pick the window that I want my graph to be in. So I'm going to press zoom again, which is in just the middle of the upper row, and the very first one is zoom box. So it's already highlighted, and I press enter to choose it. Now what I want to do is I want to scroll and put my cursor on the corners of my box, but the diagonal corners, and it doesn't matter whether it's the bottom left and top right or top left and bottom right. We just have to scroll corners. So I'm going to use my left arrow key. You can sort of see the cursor. You see it moving just slightly to the left of the origin. So I want to make sure that I move far enough out so that I can include my whole function. So I want to get past basically the left hand side of my function, and then I'm going to scroll up so I can get up to the top of my function. It's going slowly, sorry, but we're going to scroll up. We want to get all the way above the uppermost limit of my function, and then once I'm up there, I'm just slightly above it. That's okay. I'm going to press enter. And now I'm going to do the same thing, but that's basically what I've done is I've given my calculator a limit, and now I'm going to scroll right and down to get to the opposite corner. So I need to scroll to the right. Now scroll down. See, as we're scrolling down, it's highlighting the box that we want, and then you're going to press enter to tell the calculator to zoom in on that part. Here's a better picture of our graph. Our second function that we want to graph is r squared equals 9 sine 2 theta. So let's go back to the y equals button. So the y equals button is going to have our function that we just typed in. We want to clear that function out, so just press the clear button, which is in the far right hand column. And we're going to type in, we can't type in r squared. Notice our choice is just r equals. So what we have to do is actually plug in, if we took the square root of both sides, we would end up with r equals, right? But we would end up with r equals positive and negative square root of 9 sine 2 theta. So that means that we have to plug in our function twice. So we have to plug in the positive square root, so we're going to type in second, and the square root button is the blue key to the x squared button in the first column, and we're going to type in 9 sine 2 theta. So 2, and then remember that theta is the x button, and we're going to close our parentheses, and we need to scroll out from underneath the radicals. So scroll to the right. Now that's the positive square root. We're going to scroll down to R2. Now we have to type in the negative square root. So you're going to type in the negative key and not the subtraction key. The calculator will be confused and tell you have an error if you put a subtraction key in there. So we want to press in the negative. Now I could just type that same function again, or here's a shortcut. I've already typed it in once, so I'm going to use my shortcut button, which is my green button or the alpha button, and then F4, which happens to be alpha trace. And my choices are now those Y equals buttons, or in this case R equals. I've plugged my function into R1, so I'm going to choose that. That's what's highlighted. So to choose it, press enter. And now basically I've just told the calculator use the same function that I've typed in R1. So I'm going to graph this. I want to go to, this time let's just go to zoom decimal. So we're going to go to zoom, and then we're going to scroll down to number 4, or again you can simply type number 4, press enter. And the blue function is the positive square root, and the red function is the negative square root. Notice that that function ends up graphing right on top of each other. Sometimes the square root function, when it's r squared, sometimes it does graph on top of each other and sometimes it doesn't. So it is good practice to use or to graph both the positive and the negative square root. That concludes our lesson on graphing polar equations.